In this video, we're going to take a look at factoring the algebraic expression. It's called a trinomial, x squared plus bx plus c. Now, specifically, this is when the coefficient of the x squared or quadratic term is 1. There will be another video called factoring ax squared plus bx plus c when the coefficient of the quadratic term is not 1. So specifically just when there's a 1 in front of the x squared or whatever the variable is. Now, when you're factoring a trinomial such as x squared plus bx plus c, the intention is to write the trinomial as the product of two binomials. And factoring and multiplying or expanding are opposite operations. So we're going to take a look at an expanding to get an idea how to factor. So when you go in this direction, take the x plus 3 times the x plus 4 and multiply them together, or expand that, you get this trinomial. We'll talk about specific terms here in a moment. When you take this trinomial and attempt to factor it, you're trying to write it as the product of two different binomials, such as the x plus 3 and the x plus 4. Now, if we were to multiply these together, x times x is x squared, x times the 4 would be the 4x, 3 times the x would be the 3x, and 3 times 4 is 12. So you can just multiply each term in here by each term in here. You get these 4 terms, and the 3x and 4x add to 7x, and so it simplifies to x squared plus 7x plus 12. Now, so the purpose of this example is to show you, well, if I want to take this and factor it and write it as the product of x plus 3 and x plus 4, how do I know it's 3 and 4? Well, the 7x comes from adding the 3x and 4x. Notice that 3 and 4, or this 3 and this 4, add to 7. And the 12 here comes from multiplying the 3 and the 4. So the 12 on the end is actually the product of these two numbers. So the numbers after the x or y, or whatever the variable is, are always going to be the sum. They add to this number, the coefficient of the linear term, and they multiply to the constant on the end. And so we use that idea in factoring these 5 examples below. So it says factor each trinomial if possible. We'll get into the if possible at the end here, because there are times when it's just not possible to do this. There aren't two factors that multiply to that particular trinomial. And so in the first one, x squared plus 10x plus 16, we're looking for two numbers whose sum is 10 and product is 16. And so the two numbers that add to 10 and multiply to 16 would be 2 and 8. And so because 2 and 8 add to 10 and multiply to 16, then the factors of this would be x plus 2 and x plus 8. And you can always check any factoring by expanding the factors together, and you should get your original expression. So for example, x times x is x squared. This product is 2x. This product would be 8x, and the 2x and 8x add to 10x. And 2 times 8 would give you 16. And so that just verifies that x plus 2 and x plus 8 are the factors of this trinomial. For b, in the second one, x squared minus 3x minus 10, the sum would be negative 3 and the product would be negative 10. So the two numbers we're looking for add to negative 3 and they multiply to negative 10. And so those numbers would be negative 5 and 2. Negative 5 and 2 add to negative 3 and they multiply to negative 10. And so the factors of this trinomial would be x minus 5. Notice I said negative 5 here, so that's why it's x minus 5. And positive 2 means it's x plus 2. And again, you can multiply those together and check that it does work out to x squared minus 3x minus 10. In C, now x squared plus x minus 30, the coefficient of the linear term in the middle here would be a 1. So the sum is 1 and the product is negative 30 of our two numbers we're looking for. So we're looking for two numbers that add to 1 and multiply to negative 30. Now, when the product is reasonably large and the sum is small, that means that the two, and notice that this is negative. So if the product is negative, just like here, we had a negative and a positive. Okay, if you have two integers that multiply to a negative, then one has to be negative, one has to be positive. Now, so the product is a negative, so one's negative, one's positive, and if it adds to a fairly small number, then the two numbers are fairly close together. In this case, the numbers are 6 and negative 5. 6 and negative 5 add to 1, and they multiply to negative 30. You see, the closer the sum is to 0, the closer these two numbers are to being opposites. They're close to being opposites, not quite, but close. And so 6 and negative 5, so the factors would be x plus 6 and x minus 5. For D, x squared minus 8x plus 15. And what's special about this example, and I wanted to show whoever's watching this, is that, well, in this case, the sum is negative 8 and the product is 15. If the product's positive, and actually that was true in the first one here too, if the product's positive, then the two numbers are either both positive or they could be both negative, which is the case here. See, if they add to a negative and they multiply to a positive, well, then they have to both be negative, because that's the only way you can get two numbers the same sign to add to a negative. And so the numbers would be negative 3 and negative 5. Negative 3 and negative 5 add to negative 8, and they multiply to positive 15. And so this would factor into x minus 3 and x minus 5. I did notice after the few examples here, you don't always have x minus 5 as a factor. It actually happened in the last 3 examples, but that's just a coincidence. For an E here, we're trying to factor x squared plus 2x plus 7. And so the sum would be 2, and the product would be 7. Well, if you look at, okay, the product is 7, so the only numbers that multiply to 7 are either 1 and 7 or negative 1 and negative 7. And neither of those pairs adds to 2. So neither 1 and 7 equals 2, nor does negative 1 and negative 7 add to 2. And so that's why it says if possible here. This is one of the ones that's not possible. There are no two binomial factors that multiply to x squared plus 2x plus 7. So if that's the case, you would just say you can't do it. It's not possible to factor. And that's the end of the video.